Today we're going to talk about applying the sine and cosine ratios. So, the sine of an angle is equal to the ratio of the opposite side over the hypotenuse. So if we took angle A, our opposite side is BC, and our hypotenuse is across from our right angle. As always, it would be AB. Now, if we take cosine, our cosine of an angle is equal to the ratio of the adjacent side over the hypotenuse. So if we took angle A, our adjacent side is the side AC, and our hypotenuse is AB, once again across from the right angle. So those are the ratios we're going to use today. So how do we remember all of these? There's a shortcut, Sohcahtoa. Sohcahtoa helps us remember the trig functions sine, cosine, and tangent. The SO stands for sine equals opposite over hypotenuse. The C stands for cosine equals adjacent over hypotenuse. And our TOA stands for tangent equals opposite over adjacent, which we learned previously. So this asks us to find the ratios of sine A and sine C. So we're going to start with sine A. So let's start with, so we're going to write Sohcahtoa. It asks for our sine, so we know we're going to use this part of our Sohcahtoa. So the sine of angle A equals our opposite over our hypotenuse. So let's start from angle A. We know that opposite is across from it. So this is our opposite side. We know next to it is our adjacent side. And our hypotenuse is always across from the right angle. So sine, remember it's our SO of our Sohcahtoa. So sine equals our opposite over our hypotenuse. Our opposite is 18, and our hypotenuse is 82. We can reduce this to 9 over 41 by dividing by 2. Now it also asks us for the sine of angle C. So if we're using angle C, our hypotenuse is going to stay the same. This is still our hypotenuse. But notice that now this side is opposite our angle, and this side is adjacent to it. So once again, sine calls for opposite over hypotenuse. So our opposite side is now 80, and our hypotenuse is 82. We can simplify this to 40 over 41 by dividing by 2, and that's our answer. This next problem asks us to find the cosine of A and the cosine of B. So once again, we start with Sohcahtoa. This asks for cosine, so we're going to use the C part of our Sohcahtoa. So cosine is equal to our adjacent side over our hypotenuse. So, if we start with angle A, we know that the one across from it is its opposite side. The one next to it is its adjacent side. And our hypotenuse is across from the right angle. So, to find cosine, we do the cosine of A equals our adjacent side, which we just decided was 15, over our hypotenuse, which is 17. This can't be simplified, so that's all we need to do. Now it also asks for our cosine of B. So now we need to look at the triangle from the perspective of angle B. If we do that, this now becomes our opposite side. This is our adjacent side, so it's next to our angle, and our 17 is still our hypotenuse. So the cosine of angle B is the adjacent side, which is now 8, over our hypotenuse, which is 17. Now, we'll notice that sine and cosine are related to each other in a certain way. And here's how. So if we have this triangle, and this is 56 degrees. So it asks us to write the expression sine of 56 degrees in terms of cosine. Okay, so we know Sohcahtoa. We know that our sine is equal to our opposite over our hypotenuse. So in this triangle, we're going to make our opposite side, right, opposite our angle, we're going to call that the red side. So this is going to equal our red side, and then we're going to make our hypotenuse our blue side. So we know the sine of 56 degrees is equal to our red side over our blue side. But they want us to write red side over blue side in terms of cosine. Well, we know that cosine is adjacent over hypotenuse. Well, our blue side is our hypotenuse, so we're okay there. But we need to make sure our red side is now our adjacent side. So our red side is adjacent to this lower angle. So if we can figure out the degree measure of that lower angle, the cosine of that would give us our red side over our blue side. Since we know a triangle is 180 degrees, and we have one right angle, which is 90, 180 minus 90 is 90 degrees. So we know the other two angles have to add up to 90 degrees. So to figure out our missing angle, we can just do 90 minus 56, and that gives us 34 degrees. We know this angle is 34 degrees. So if we take the cosine of that angle, we now have our adjacent, which is our red side, over our hypotenuse, which is our blue side. So the cosine of 34 degrees is the same thing, or is equal to, our sine of 56 degrees. So in order to switch an expression from sine to be in terms of cosine, we simply do 90 minus the degree measure that we were given. So in this one, sine of 21 degrees, we know that equals the cosine of 90 minus 21 degrees, which is simply the cosine of 69 degrees. The same is true for going from cosine to sine. So all we have to do to write cosine in terms of sine is sine of 90 minus the degree measure they gave us, in this case 35. So the sine of 90 minus 35 is simply the sine of 55 degrees. Once again, down here the cosine of 8 degrees is the sine of 90 minus 8 degrees, which is simply the sine of 82 degrees. So that's the relationship between sine and cosine. Now we're going to use our sine and our cosine and even our tangent, our trig functions, in order to find the missing values. So we're going to start by writing our Sohcahtoa. This is going to help us to figure out which trig function we're going to need to use to find our missing values. So we're going to start with the angle that they gave us, our 40-degree angle. We're going to label our triangle. So we can see that y is our opposite side. X is obviously our hypotenuse because it's across from our right angle. And 8 then is our adjacent side. So we're given our adjacent side. If we wanted to solve for x, we'll start by solving for x, we're looking for the hypotenuse. So we have the adjacent and we're looking for the hypotenuse. That means we can look at whichever trig function uses the adjacent and the hypotenuse. So we go to our shortcut, and we see here we have our ca, which is cosine equals adjacent over hypotenuse. So now we can use that to solve for our hypotenuse, our x value. So our cosine of 40 degrees equals our adjacent side, which in this case is 8, over our hypotenuse, which is x. Now remember, to solve for x, we have to get x out of the denominator, so we're going to multiply both sides by x. So we have x times the cosine of 40 degrees equals 8. Now we have to get x by itself, so we're going to divide both sides by the cosine of 40 degrees. If we put this in a calculator, we find that x equals 8 divided by the cosine of 40, which is roughly 10.4. Now we have to go back and solve for y. The part of our triangle that is y is our opposite side. So we're looking for our opposite, and we have our adjacent. We always want to go back to the original values in the triangle in case we made a mistake, or also just because the numbers we solved for are rounded numbers. So we're going to go back to what they gave us, which is the adjacent side, and we're looking for the opposite side. So we're going to look at which trig function we need that uses opposite and adjacent. If we go back to our shortcut, we can see our TOA uses opposite and adjacent. The O and the A are opposite and adjacent. So we know that the tangent equals the opposite over the adjacent. So the tangent of 40 degrees, our angle, equals our opposite side, which in this case is y, over our adjacent, which is 8. Now to solve for y, we can simply multiply both sides by 8, and we can put 8 times the tangent of 40 degrees in our calculator, and we get roughly 6.7 equals our y value. We're going to do the similar thing on this problem. Once again, we're going to use any of our trig functions, sine, cosine, or tangent. So we're going to write out our Sohcahtoa. So we can label our triangle as well. So we're going to start with the angle that they give us, our 72 degrees. Opposite our 72 degrees is our x. 3 is our hypotenuse. And y is our adjacent side. So if we're solving for x, we are looking for our opposite side, and we have our hypotenuse. So we go back to our trig shortcuts. Which one uses opposite and hypotenuse? Sine, right? Sine is opposite over hypotenuse. So we can write that the sine of our 72-degree angle equals opposite, which is x, over our hypotenuse, which is 3. To solve for x, we simply multiply both sides by 3. 3 times the sine of 72 degrees is 2.85, so that's our x value. Now, to solve for y, we go back to our triangle. Y is our adjacent side, and once again, remember we have the hypotenuse. So which trig function has the adjacent and the hypotenuse? That would be our cosine, because cosine equals adjacent over hypotenuse. So our cosine of 72 degrees equals our adjacent, which is y, over our hypotenuse, which is 3. We're going to multiply both sides by 3 to get y by itself. 3 times the cosine of 72 degrees is roughly 0.93. And so that's our y value. All right, once again, we can use any of our trig functions to solve for r and s. So let's write out our Sohcahtoa. And we're starting with our 20-degree angle. So we know that s is our opposite side, r is our hypotenuse, and 117 is our adjacent side. So if we're looking for s, that's our opposite side, and we're given our adjacent. So we go to our shortcut, which trig function uses opposite and adjacent, and that's our tangent, because the tangent equals the opposite over the adjacent. So in this triangle, the tangent of 20 degrees equals our opposite side, which is s, over our adjacent side, which is 117. Now to solve for s, we simply multiply both sides by 117. 117 times the tangent of 20 gives us 42.58. That's our s. Now we still have to solve for our r, for our hypotenuse. So we go back to our triangle. So r is our hypotenuse, and they give us our adjacent. So we're looking for a trig function that uses adjacent and hypotenuse. We go back to our shortcut, Sohcahtoa. We know that this is our cosine. So the cosine equals the adjacent over the hypotenuse. So we know that the cosine of 20 degrees equals our adjacent side, which is 117, over our hypotenuse r. To solve for r, we have to get it out of the denominator, so we multiply both sides by r. So r times the cosine of 20 degrees equals 117. To get r by itself, we divide by the cosine of 20 degrees. And 117 divided by the cosine of 20 degrees gives us r equals 124.5.